Before we actually launch into the topic of group data, let's go over a mathy idea that we will end up using. Suppose you were going to add 71 plus 71 plus 71 plus 71 plus 71, on and on and on and on. That's a lot of typing of 71 and plus signs. I can see the data is kind of organized and I can easily count. It looks like there are 33 of these 71s that I'm supposed to be adding up. Well, adding 71 33 times is what multiplication is all about. So 71 times 33 would give me quickly 2,343. That would save us a lot of time, and we could then sing Gloria about all the time we saved from having to not type 71 and plus signs. But this idea of recognizing that you have a lot of duplicates of the same data value is a key idea in working with group data. So again, if you find that you're going to have to add the same number up a bunch of times, don't do that. Instead, count how many there are, and you're going to multiply the number by how many there are. We are going to use the 2023 U.S. pedestrian deaths per state and Washington, D.C. So notice there are 51 values. If you add 33 and 13 and 2 and 2 and 1, you get 51. We don't actually have the full set of data. Instead, we have the data organized in these categories. We had 33 values fell between 5 and 136. 13 fell between 137 and 268. 2 states had pedestrian deaths between 269 and 399. And then there were 3 categories that didn't have any. This is data that is very skewed to the right. So there was, a big gap where there aren't any states with those values. And then 2 states had between 794 and 925 deaths. And then 1 state had between 926 and 1057. That actually happened to be California, that has a really high population, and so it drives up the pedestrian deaths just by natural higher numbers of people. Again, we don't have the exact data. Excel made kind of odd listings in terms of the categories. So like that first category, you should really read as it goes from 5 to 136. There's not going to be 136 and a half deaths. And then the second category picks up at 137. So anyway, just keep that in mind that we have discrete data here. And so in the long run, we should really work with the whole numbers. Even though we don't have the actual exact data, we can get decent estimates of the mean, median, and standard deviation by using the categories and the counts. What we are going to do is we are going to find the middle of each of the categories. The first category goes from 5 to 136. Excel actually listed it from 5 to 136.5. So I'm going to use the actual values that mark the beginning and end of these categories, even though we have whole data. And we are going to end up rounding to the nearest whole number. So the middle of the first category is 71. I got that by adding 5 and 136.5 together and dividing by 2. They gave us a middle of 70.75, but let's round up to the nearest number since we're talking about number of deaths. And the second category, the middle is 202. I got that by taking the low end point and the high end point and adding them and dividing by 2. That gave me a middle of technically 202.25, but we're going to round to the nearest whole number. Then the third category, the middle is 334, doing the same thing, taking the low and the high of the category and adding them and dividing by 2, giving us 333.75, round to the nearest whole number. I'm going to not bother with the 3 categories in the middle because there aren't any data in it, and so it's not going to affect our numbers. It's okay for us to ignore them. And then the second to last category is going to have a middle of 860 between 794 and 925.5. And the last category has a middle of 991. That's in between 925.5 and 1057. So this is how we are going to look at this set of data. We have 33 71s and 13 202s and 2 334s, 2 860s, and 1 991. So to find the mean, we're going to add all the values up. But remember back at the beginning of our video that we're not going to take the time to type 71 plus 71 plus 71 33 times. Instead, we're going to save ourselves time and multiply 33 times 71. And we're not going to take the time to add 202 plus 202 plus 202. Instead, we're going to take 13 times 202. And then we're going to add 334 twice, and then 860 twice, and then our last value was 991. So if you did take the time to add all 51 values up, you would get 8,348. It's just we saved ourselves time by noticing that there was a bunch of duplicates. So the sum of all 51 values is 8,348. Divide by 51, that's how many there are, and we get a mean amount of pedestrian deaths of 163.69. Again, you could round to 164 if you really wanted to make it a whole number. It's not really going to matter. I'm going to leave it as 163.69 though. Now, if we were going to estimate the median is the middle value. So you list the values from lowest to highest and you pick the one that's in the middle. So we're going to do that same thing with this data. It's just we have a lot of duplicates. If you have 51 values, the position of the median should be 51 plus 1 divided by 2, or 52 divided by 2, which is 26. So the 26th data value should be the median. But 33 of them are 71s. So the 26th value actually falls in the first category. So we are going to just use 71 as an estimate for the median. You should have already covered how to find standard deviation. It is an average amount that the values differ from the mean. We are going to follow those same steps. However, we have a set of data that has a bunch of duplicates. The number 71 shows up in our set of data 33 times. The number 202 shows up 13 times. 334 gets listed twice. 860 gets listed twice. And then 991 is only listed once. So following the idea of finding the standard deviation, you find how different the data values are from the mean. Our estimate of the mean was 163.69. So 71 minus 163.69 is negative 92.69. And then the difference between 202 and the mean is 38.31. The difference between 334 and the mean is 170.31. The difference between 860 and the mean is 696.31, and the last data value, 991, has a difference from the mean of 827.31. So those are the deviations. And again, we want to average the deviations, but we can't just add the deviations because you'd end up getting 0 all the time. So we square the deviations to get a list of positive values that we can add. But when we actually add the squared deviations, we have to remember that 33 of our values were 71 and 13 of our values were 202. 2 of them were 334, 2 of them were 860, and 1 was 991. So when I go to add the squared deviations in order to average them, I'm going to take 8,591.4361 plus that, but 33 times. So take 33 and multiply by 8,591.4361, then add 13 times the next squared deviation, and then add 2 times the next squared deviation, and then 2 times the next squared deviation, and then our last category only had one data value in it, and so we just, technically you could just add the 684,441.8361. So that gives us the sum of all the squared deviations. We do not have the full set of data, so you really should treat all group data as if it's a sample. And so we're going to make the standard deviation slightly bigger by dividing by n minus 1. So 51 minus 1 is 50. So when we find the average of the squared deviations, we're going to divide by 50. That gave us 38,554.6. Take the square root to dampen the effect that you squared, and you get 196.353 as the standard deviation for the pedestrian deaths per state. By the way, a little review about coefficient of variation. This is a really good example to observe. Our standard deviation is actually larger than our estimated mean. So when we find the coefficient of variation, you take the standard deviation, you divide by the mean, then turn that ratio into a percent, we get 120%. Anything over 50% is indicating widely varied data. So this is very spread out data. Most of the values were in the lower categories, and then there were just a few states that had pedestrian deaths that were much higher than the other states. So anyway, this is an interesting set of data to look at because it is very skewed to the right, and we get a coefficient of variation of 120%. So here is a set of data for you to practice. We're going to use this group data about calories burned daily, and we will let you practice with these 5 categories in estimating the mean, the median, and the standard deviation for the set of data. So again, we do not have the full set of data. Instead, the data has been organized in these 5 categories. But with that organization, we'll be able to get a reasonable estimate of the mean, the median, and the standard deviation. So pause the video and work out the 3 values like we did in the previous examples. Okay, so do you feel pretty good about your estimate of the mean, the median, and the standard deviation? Step would have been to find the middle of all the categories. So if you averaged 1,950 and 2,160, the average was 2,055. So that's what we're going to count all 3 of the first values as 2,055. Then the second category, the average between 2,160 and 2,370 is 2,265. So 10 values in the second category are all going to be considered 2,265. The third category, if you average 2,370 with 2,580, you get 2,475. So 6 values in the third category will be considered that value. And then there were 7 values in the fourth category, and if you average 2,580 with 2,790, you get 2,685. And then the last category had 5 values in it, and if you average 2,790 with 3,000, you get 2,895. So our data had 31 values. 3 of them were 2,055. 10 of them are going to be considered 2,265. 6 of them are going to be considered 2,475. 7, 2,685, and then 5, 2,895. So to estimate the mean, we're going to add all of our data, but 3 of the data values are 2,055, 10 of the data values are 2,265, 6 of the data values are 2,475, 7 of the values are 2,685, and then 5 of the values are 2,895. So adding all 31 values is equivalent to doing the numerator of that fraction, 3 times 2,055 plus 2,265, etc. Then divide by 31, because that's how many data values there were, and we get a mean of 2,481.77. So that is our estimate of the number of calories burned daily from this grouped set of data. The median of a set of data with 31 values will have a position of 16th value. 31 plus 1 divided by 2 is 16. The 16th value would fall in the third category. 3 of the values were in the first category, 10 were in the second category. That's 13 values. So if you kept counting to find the 16th value, it would be in the third category. All of the values in the third category are being considered as 2,475. So we're going to choose 2,475 as our estimate of the median. Then working through the standard deviation steps, we need to find the difference between the data values and the mean. Our mean is estimated to be that 2,481.77 that we found a couple of steps ago. So if you take 2,055 and you subtract 2,481.77, you get negative 426.77. If you take 2,265 and you subtract 2,481.77, you get negative 216.77. 2,475 minus 2,481.77 becomes negative 6.77. And then 2,685 minus the mean is a difference of 203.23, and 2,895 minus the mean is 413.23. We're trying to find the standard deviation, so we average the squared differences. So take the square of those deviations, and that's where we get the 182,132 and the 46,989, etc. So we want to average those squared deviations, but 3 of them are the first one, and 10 of them are 46,989, and 6 of them are 45.8329, and 7 of them are 41,302, and 5 of them are 170,759. So when we average the squared deviations, instead of adding up 31 values, we can more quickly realize that 3 of them are the same thing, and 10 of them are the same thing, and 6 of them are the same thing, etc. So take the correct counts times the squared deviations, and you should have gotten 2,159,477.42. Again, we don't have the full set of data, so we're certainly kind of looking at this as like a sample. So divide by 30 and not 31, and we get approximately 71,982.58. Then take the square root to dampen the effect of having squared. And our estimate of the standard deviation for the amount of calories burned is 268.296 calories. Notice with this set of data, our coefficient of variation turns out to be only 10.81%. So this data was much more closely packed together relatively than the set of data about the pedestrian deaths per state. The coefficient of variation here is reasonably small, whereas the other one was extremely large. I hope this gave you a decent overview of working with group data. A lot of times you actually have a full sample or population set of data, but sometimes you're given data grouped in categories and you don't want to just stop and say, I can't find the mean or the median. Instead, you can get decent estimates using the methods that we presented in this video.